Okay, students, today we are going to see what is analog to digital converter and why do we need it. Okay, so let us see first analog versus digital signal. Now, analog signal is the one which is continuously varying with respect to time, and a digital signal is the one which is varying in some discrete steps, and that is a discrete signal basically. And digital signal is something that is uh, 0 and 1, related to 0 and 1. So what analog to digital converter does? Analog to digital converter basically converts the analog signal into the digital signal, that in turn is acceptable by the CPU, and thereafter it will be displayed onto the either LCD, LED or monitor, whatever is there. So this particular figure is schematically showing you the microcontroller connections to the sensor via analog to digital converter. What is sensor? Sensor is something that converts the change in signal from one form to another form. For example, temperature sensor. PT100, it converts the change in temperature to change in resistance, that in turn it can be converted to change in voltage with the help of the bridge circuit, and that in turn it could be given to analog to digital converter. Analog to digital converter will give the digital output, which in turn will be given input to the CPU, that is nothing but a microcontroller or microprocessor, and then it will be displayed on LED or LCD display. This is what is the purpose of analog to digital converter and is the requirement of A to D converter. Now, the second figure, that is nothing but this figure, it shows you the schematic of analog to digital converter. Basically, what is analog input? Analog input is certain voltage that is provided as input to the chip. Typically, it is varying from 0 to 5 volts. And we give one start of conversion command and we provide certain reference voltage. For example, we provide the reference voltage as 5 volts. Analog input voltage is varying from 0 to 5 volts. The corresponding binary data will be available across D0 to D7, right? And this is what is the typical need of analog to digital converter to provide the binary output data. Now let us see what is the process of this analog to digital conversion. Okay, so there are two related steps in analog to digital converter. One is sampling. What is sampling? That we take the sample after a particular sampling period or sampling interval. And what is quantization? Quantization is taking out a subset from a particular step. Mathematically we can call it. For example, if we sample the signal at some time instance t, 2t, 3t, 4t, where capital T is nothing but a sampling period, and corresponding values we are getting 2.1, 3.3, 4.4, like that. So if it is 2.1, then naturally we have to convert it to truncate it to 2. If it is 3.4, we have to truncate it to 3. If it is 4.8, we have to truncate it to 5. So this is what is called as quantization, and in quantization there is a error in the form of truncation, and that is called as quantization error. So the analog signal is extracted usually at a regularly spaced time interval, because most of the time we use uniform sampling. There are other forms of sampling, but we don't bother about it right now. and these samples have the real values. I already told you that it is 1T, 2T, 3T, 4T and like that. And quantization, the samples are quantized to the discrete levels. Each sample is represented by a digital value. For example, 2 is represented by 1 0, 3 is represented by 1 1, 4 is represented by 1 0 0 and like that. See, this is the typical pin diagram and pin description of ADC 0801. 08 is the series and 01 stands for there is only one analog input. There is another IC that is 0808, so it has 8 channel input, but in this case we are going to discuss about 0801. So pin number 1 is nothing but chip select. So if you want to continuously select the analog to digital converter, you have to connect it to ground. Pin number 2 is RD bar. RD bar signal is nothing but a read control, and WR bar is the write control. So it is also known as, in some cases, start of conversion signal, because we have to provide a pulse high to low, and that in turn will command the analog to digital converter to start its conversion from analog value to the digital value. Clock in is certain clock is needed to analog to digital converter, as it is a digital IC and every digital IC needs a clock, but this clock has to be necessarily less than the clock of the microprocessor, and its range is specified for a particular IC, and depending on the range of the clock, its conversion time will be decided. Typical conversion time for such ICs is 80 microseconds, like that, not less than that. So INTR is nothing but the interrupt. Interrupt is basically the end of conversion signal that is provided by the micro ADC. Then after V in plus and V in minus, these are the two analog inputs. It could be positive, it could be negative, and A ground is nothing but the ground for analog circuit. Similarly, D ground is nothing but the ground for digital circuit, because both our analog and digital circuits are isolated, so they have different grounds. This is V reference by 2. Okay, so for example, V reference is 5 volts, then we can apply here 2.5 volt. And these are the corresponding digital output, that is nothing but from DB0 to DB7. And pin number 19 stands for resistance connection for a clock, and pin number 20 stands for VCC. Typically it is 5 volts. Okay, so this is what is the pin diagram and pin diagram description of 0801 analog to digital converter. So it could be 0801, it could be 0804, it could be 0808. So some configurations will change, but basic pin descriptions will remain same. Now I have discussed that this is 0808 or 0809. Both are having 8 analog inputs, right from IN0 to IN7, and there are 3 channels to select any of the input 0 to input 7. For example, this ABC is 000, IN0 is selected. If it is 001, then IN1 is selected, and like that. Pin number 6 is start of conversion, 7 is end of conversion, and remaining are same. Okay, output enable is for chip select, and these are the digital. This is least significant digit and this is most significant digit, and address latch enable, one signal is there, and other pins are almost discussed. Okay, so this is the pin diagram and this is nothing but a functional diagram of 0808. This is one of the schematic diagram, right? This diagram is showing you that how we can connect the analog to digital converter. Through 8255 it is connected to microprocessor, right? Because microprocessor needs ports and ports are not inbuilt in 8085. That is why through 8255 only we can connect the analog to digital converter, because we have to send certain control signals to ALE start of conversion and to select the channel of this 0808, and in turn we have to monitor the end of conversion. So those signals are connected to PC0 to PC7 pins of port C of 8255, as we can individually operate the pins of the port C, and analog input 0 is connected in this particular case. Now the clock from microprocessor, it can be divided with the counter circuit or counter IC, and we can connect it to the clock of the A to D converter. And most of these signals V reference plus output enable VCC, they are connected to plus 5 volt, so that the output is enabled all the time. V reference is 5 volt and ADC is VCC is necessarily required for A to D converter. And V reference minus and ground is connected to ground because they are at level 0. So this is the schematic diagram how they are connected, and 8-bit digital control output shall be given to port A. End of conversion signal will be given to PC7 through PC7 to 8255, and PC3 will give address latch enable as well as start of conversion signal to A to D converter, and PC0 to PC2 will determine, so they should be necessarily 0 if we want to select IN 0 as input, 0 for analog to digital converter. So this is one of the schematic diagram, and based on this diagram we can write the program. The program is typical, it is very easy to understand and we can write it quite easily. Okay, so before we start writing the program, we have to understand few things, that in this circuit the channel used is IN0. So ABC signals which are connected through PC0, PC1 and PC2 should be necessarily 0, 0. Why it should be 0? Because we want to select the IN0. If we would have needed IN1, we would have selected it as 0, 1. If we would have needed IN7, we would have selected all of them as a 1, that is 0, 7H. Okay. Now to enable the start of conversion, first PC3 is made high and then it is low without changing the selection of the channel. So how it is made high? If we want to make them high, in that case this PC3 need to be 1. What is PC3? PC3 is nothing but start of conversion signal. Okay, so first of all we'll keep it 1. So for that the port C control word or port C word will be 08. But when we want to do it 0, PC3 we want to do it 0, then the control word is 00. So first we have to send 08 to port C, thereafter we have to send 00. Okay, so this is what we need to understand before we start writing the program. Now the program is quite easy. First of all, we have to load the control word 98 to accumulator in order to initialize 8255 to work port A and port C as input port and port C lower as a output port. Okay, so we want the port C upper as a input port because we are accepting signal through port C upper and we are providing signal to port C lower. So for that, we have seen the control format for 8255 in input output mode. So for input output mode, this bit 7 necessarily should be 1 and we are using the port A and port B as a input port. So port A we are using in mode 0, that is why it is 0 0, and port A should be input port, that is why this PA is equal to 1. Port C upper should also be input port, that is why it is 1, and port B also we are using in mode 0 and it is used as a input port it should be output port, and port CU should also be 0 for using it as an output port. Accordingly, the control word format for the control word register comes out to be 98. Are you getting it? Okay, so that is why we have to load it to accumulator by using the command mvi move immediate data 98 into accumulator. Then we have to copy this to the port control word register for which the port address is 03. That is why we have used the command out 03h. Are you getting it why we are done? Because here we are assuming that the port A address is 00, port B address is 01, port C is 02 and control word register address is 03h. Okay, next what we have to do, we have to load accumulator with 00 and we have to send it to port C lower in order to select IN0 channel. That is IN0 as a channel. We already seen why we have done it, because in that case the port C lower signals PC0, PC1 and PC2 will become 00 and 000 and input channel 0 IN0 will be selected. Okay. Thereafter, in order to send a low to high pulse to this start of conversion, we have to load the control word 08 as we have seen earlier. So 08 will be loaded into the accumulator and we have to load it to 02. What is 02? 02 is once again the port C lower, port C address. So it will send a low to high signal. These two commands will send the low to high signal to the analog to digital converter, that in turn will provide the start of conversion command. Now what we have to do, that we have to load accumulator with 00 value and we have to send it to 02, that is nothing but port C. Why we have done it? Because we already sent the command low to high and now once again we have to ALE signals we have to low down and a pulse is applied from high to low. Now what we have to do, that we have to read the end of conversion. The end of conversion is connected across PC7. Okay. So what we'll do, we'll use the command in 02h. What is 02? 02 is nothing but the address of the port C. Okay. And what we are doing, we are using a rotate left command. Why we are using that? Because PC3 until it remains 0, this array L command won't produce any carry. But if that PC3, that is end of conversion, if end of conversion means conversion from analog to digital is over, in that case one high signal will be generated across end of conversion, which is at PC7, and that in turn will change the bit PC7 from 0 to 1, and RAL, it will rotate it to the left and it will rotate with carry. So the PC7, which is 1, will be copied into the carry, and we have provided a conditional loop, jump if not carry read. Means unless and until this PC7 bit will become 1, it will go on jumping, because it is jump if not carry. But if that PC7 becomes 1, then this RAL command will transfer it to where it will transfer, RAL command will transfer it to carry, and in that case this condition for jump if not carry will become false and it will come out of the loop. Once it come out of the loop, we know that the digital data is connected across the port A, which we can read it from 00 address. Port A address is 00. So in 00 it will read the command and thereafter we are using STA2100, whatever we have read it from the output of A to D converter, we have to store in this particular memory location 2100H, and here we will stop processing. So this is how the program of analog to digital converter it works. So for writing the program, the connections should be clear to you and the operation of the analog to digital converter should be clear to you. Okay, I hope you have understood this program very well, and thank you very much for patient hearing. What is the execution of the program? After this we will check the memory location. Now here we are reading the real-time values, so every time the memory location will be overwritten. Basically the process is we connect a potentiometer across. There are three terminals for potentiometer. One is the variable terminal that we connect as input across IN 0, and other two terminals we connect it to VCC and ground. Now if analog input voltage is 0 volts, the digital output will be 00H. It means 8 times 0. And if it is 5 volts, then naturally the digital output will be 2 to the power 8, because it is 8-bit resolution A to D converter. So it will be 1111 8 times. That is nothing but FF, right? Now whatever is in between, for example 1 volt, so 1 volt is 1/5 of 5 volt, so 1/5 of this FF, that is nothing but 34H, will be displayed as digital out, and like that if it is 3 volt 94H. So this is how the analog to digital converter works. If you want to implement a closed loop control, analog to digital converter is very important, and in most of the cases the closed loop control is required. For example, if you want to regulate the voltage of DC to DC converter, in that case you need to provide the feedback and you need to use the analog to digital converter if you want to generate the PWM by the digital processor. Okay, so I hope you have understood the analog to digital converter. Thank you very much for patient hearing.